Hello everyone, we are Team Vision X and we are working under this theme Smart Public Health Management, and our problem statement is Smart Health Solution for Solapur Municipal Corporation. So today, let me briefly explain the public health data challenge in Solapur. Currently, Solapur's public health systems run on multiple disconnected data sources. Hospitals, laboratories, ASHA worker reports, and municipal records all function separately without a proper shared data platform. Because of this fragmentations, officials lack real-time visibility into what is happening across the city. As a result, outbreak detection is mostly reactive. Disease trends are often recognized only after community spread has begun, delaying response measure and increasing risks. Another issue is manual and inconsistent reporting. Many entries are often paper based or uploaded late, which affects both accuracy and timeliness of health data. The system also lacks ward level intelligence. Authorities cannot easily monitor micro level patterns, making targeted interventions difficult. Finally, there is no live tracking of critical resources such as hospital beds, medicines, ambulances, or vaccination stock. This leads to inefficient allocation during emergencies. So, to address these challenges, Solapur needs a unified, real time municipal health intelligence system that enables proactive, predictive, and data driven decision making.
SMC Health OS system is a unified municipal health intelligence platform designed to transform Solapur's fragmented health ecosystem into a real-time, predictive, and accountable digital network. It connects citizens, field workers, healthcare facilities, and municipal administrators into a continuously learning sense, analyze, act system. Now, how does it address the problem? First, it unifies disconnected systems by integrating clinics, hospitals, laboratories, ASHA reports, and government schemes into a single interoperable health data platform. Second, it enables early disease detection using ward-level trend analysis, anomaly detection to predict the outbreak before they escalate. Third, it ensures real-time resource visibility, including hospital beds, medicine stocks, vaccine availability, and ambulance readiness across wards. It also supports targeted interventions by identifying high-risk individuals such as malnutrition children, high-risk pregnancies, and chronic patients for proactive follow-ups. Finally, it digitalizes, empowers, and the field workers through automated task lists, reminders, and offline data capture with smart synchronization. What makes it innovative? Unlike traditional dashboards, SMC Health OS integrates predictions with operational execution. It provides ward-level microintelligence for precise interventions. It includes an accountability automation engine to reduce data misreporting and delays. It ensures citizen-centric digital access, including multilingual interfaces, appointments, vaccination alerts, and emergency notification. And importantly, it is scalable, designed to expand across ward and new public health programs without system redesign.
Greetings, everyone. I am Naman Mani, member of Vision X. Starting on with the technical approach. So basically, we designed the technical approach, the methodology, implementation process, keeping in mind that we have a distributed, fragmented data. So the first step itself was ingestion and standardization. Basically, we created MCP servers to extract data from multiple databases, which might be health information systems of Solapur, which might be municipal corporations data, and we create a unified context, basically, or your unified data, so that we could address all that data at once. Next part is AI engine, which basically uses lab results, OPD spikes, and citizen symptoms of a singular area to generate a score for what, basically ki how much disease spread is there or what kind of risk is in the society. Let's say there is a high score, so the third loop, that is the response loop, comes in, which is basically high risk area. For high risk areas, field tasks are assigned for ASHA workers, which are obviously validated from municipalities. Now, when they address there, they get a form to fill, which works as a validation part, where they give their geotagged images, which is then verified by AI and then proceeded to the municipalities for cross verification. The next part is front end and technical stack that has been used. So for technical stack, we have chosen front end. For front-end part, we have React Native and React.js. React Native works for both Android and iOS development. React.js works for both website perfectly. We have emphasized on using speech-to-text models and translate APIs for making so people of Solapur comfortable in the native language or the language they are comfortable with to be using throughout the app, so that they get a personalized experience. For backend and orchestration, we have used Node.js and Python for keeping AI and the website in sync. For database, we have PostgreSQL, as we are handling both JSON database as well as a relational data from hospitals. We have Redis for real-time information caching as well as triggering the IVRs. We have AI and a predictive engine for detecting any anomaly, disease spikes. We have used APIs as Twilio for real-time SMS sharing as well as WhatsApp information. We know users' data is important, so we have used ABA ID and DigiLocker SDK for login purpose, so that all the data is kept in. So all the secure data is properly logged in people's trusted environment. We just create a token to access view data on the user's permission as well. So that's how we protect users' PII. Continuing on with the subsystems, we have basically 7 subsystems listed. The first subsystem is citizen service and engagement, where basically citizens are involved and their interaction with the app or the basically the whole software. So there they can create appointments, get nearest hospital, get the symptom report, which is basically they give their symptoms and the app give them required referrals. They get address their queries and the alerts. Now here they can get booking confirmations, awareness alerts, etc. For the fieldworks enablement, basically this is where the ASHA and field staff operations come under in. Their field report is submitted through the app. Furthermore, they can give logs, medicine requests, and other stock requests. Data acquisition is basically in the collection of health data from the hospital's platforms of a person or a specific hospital. Unified health data platform is basically all the data is stored properly as a registry and can be used furthermore. Surveillance, analytics, and prediction module works for prediction of diseases through ward risk score, basically as explained earlier. Here, basically a ward risk score for every ward is generated. Decision support in governments come as the next module, where policies are taken down or a key suggestions are given to the government. And the last part is operation infrastructure monitoring. Basically, we have real-time status of bed status, ICU data, and stock reports. Basically, all the data of hospitals. So in case of emergencies, we can provide emergency stocks from the nearest hospital or at the same time from retailers as required. Okay. So now moving on to the architectural diagram, here we have segregated into five different blocks. First one is the user interaction layer, basically where all users are involved: the citizens, the administrator, the critical hospitals and lab staffs, and the field workers. Then is the application layer, what applications is first the citizen service, citizen engagement through community platforms. Then there is decision governance, there is operation infrastructure monitoring, then there is surveillance, and there is field workforce enablement. Then the next part is the data layer, where all data gets accumulated. So this is basically infrastructure database. Then there is citizen registry, there are health records, there are historical analytics, and then there is a scheme and beneficiary database. Next is the integration layer, where basically we say what all are being integrated into it. So there are APIs like Twilio, then there are MCP servers, then there are APIs for SMS and WhatsApp. We have rich databases, then our SDK management, then we have municipal database that is being used, and hospital lab system. A brief architecture diagram on how all the connections are made and in what cases has been attached in our report. So please go through it. Thank you so much.
The feasibility and viability of a smart public health management system for Solapur Municipal Corporation has been successfully evaluated across technical, operational, financial, and governance dimensions. From a technical standpoint, the system is built using proven and scalable technologies, including mobile applications for field data collection, cloud-based infrastructure for centralized data management, GIS-enabled visualization for ward-level instance, and real-time dashboards for administrators. Multilingual support in Marathi, Hindi, and English ensures accessibility for both citizens and field workers. Operational feasibility is achieved by aligning the platform with existing municipal healthcare workflows, including ASHA worker processes and hospital reporting mechanisms. A phased board-wise rollout strategy is proposed to minimize disruption, enable training, and ensure smooth adoption. Financially, the solution follows a modular and cloud-native architecture, reducing upfront infrastructure cost while allowing incremental scaling based on municipal capacity. Policy alignment is ensured through consent-driven usage, role-based access control, and compliance with national digital health guidelines. We also recognize key implementations challenges such as data accuracy, stakeholder participation, digital literacy gaps, and privacy risks. Targeted mitigation strategies including automated data validation triggers, simplified stakeholder onboarding, multilingual voice assist interface, and strict access governance mechanism have been incorporated into this design.
Hello, I'm Jasmine and I'm explaining impact and benefits of our topic. So the first is the citizen. So we provide ward-wise and disease alerts, vaccination reminder, nearby hospital and labs, and trusted health information in local language. This improve healthcare access, reduce panic, and help people take early action. For hospital and labs, it gives real-time bed and stock status, early outbreak signals, and digital emergency coordination. So this result is faster response, better resource utilization, and reduced workload. For municipal authorities, we offer ward level dashboard, outbreak detection, and centralized health data. These enable data driven decision, efficiency budget use, and faster policy action. For the cities, we strengthen preventive and emergency care, reduce disease spread, and build a scalable public health system. In short, VisionX turn public healthcare into a smart, preventive, and data driven ecosystem. Thank you.